Example 1. When you add radicals like radicals, it's like saying that you have 5x plus 2x. If you have 5x plus 2x, it would be 7x. But we know that it's the square root of 5, so if we have 5 square roots of 5 and 2 square roots of 5, that would give you a total of 7 square roots of 5. Example number 2. Perhaps you could rewrite these to get like radicals so that you could combine and simplify. For example, you could rewrite this to get square root of 2 left over underneath, and this one you could write it so that you would have a square root of 2 left underneath. So this one you can take, or you could rewrite the square root of 32 as the square root of 16 times 2, which you can take the square root of 16, which is 4, which leaves the radical 2 remaining. So multiply that by the 5 you started with, and you would end up with 20 square roots of 2. When I come back up to this one, I could rewrite the square root of 18 as the square root of 9 times 2. I can take the square root of that 9 and get 3. And if I multiply that by the 4 I already had, I would have 12 square roots of 2. So now, since I have like radicals, I can take my 20 square roots of 2, subtract my 12 square roots of 2, and that gives me a total of 8 times the square root of 2, or 8 square roots of 2. Example number 3. Squaring the square root of 11 minus 2. I would rewrite this out in long form and FOIL it. So when I take the square root of 11 times the square root of 11, I get 11. When I take the square root of 11 times negative 2, I get negative 2 times the square root of 11. Then I start with this one. Negative 2 times the square root of 2 is negative 2 times the square root of 11. And when I take a negative 2 times a negative 2, I get 4. Now I want to go back and look for like terms. If I take 11 and combine it with positive 4, I get 15. If I have negative 2 times the square root of 11 minus 2 times the square root of 11, those are like terms. I can combine them, which would give me negative 4 times the square root of 11. And example number 4 is trying to rationalize the denominator, and in order to do this, you have to use the conjugate. In the last unit, whenever you multiplied one negative and one positive, it would cancel out the yucky stuff in the middle. So, if I multiply this times the square root of 7 plus the square root of 2, when I multiply here by this negative 2 and then this positive 2, it cancels it out. So I'm going to multiply it by, like I said, the square root of 7 plus the square root of 2. Same thing on the top as the bottom, because if I multiply by the exact same thing on the top of my fraction as on the bottom, it equals 1, which is beautiful. We love multiplying by 1 because it doesn't change anything. It keeps its identity. So then, what I'm doing here is multiplying two binomials, which, to do, you FOIL. So when I FOIL that, I get the square root of 7 times the square root of 7, which is 7. Then I take 7 times the square root of 2, which if you wrote that out, it would be the square root of 14. That might be easier to write on that one, the square root of 14. I left it as showing you that I'm just multiplying those two. Then if I come up and take negative the square root of 2 times 7, that would be a positive square root of 14, or again, I just left it in the multiplied version so that you could see what I was doing. Negative square root of 7 times the square root of 2. Either way, that would cancel out because you have the exact same thing. One's positive and one's negative. That equals 0. Then if I come back and I FOIL the negative square root of 2 times the square root of 2, that would be negative 2. So again, this cancels out. So 7 minus 2 leaves you with 5 on the bottom. The top part is a little bit easier because you are taking a monomial times a binomial. So take negative 3 times the square root of 7, which is negative 3 times the square root of 7, and then negative 3 times the square root of 2, or you could just leave it like this.